Hello, everyone. Andrew here, talking about the Numerai data science tournament. So first of all, what is Numerai? Well, Numerai is a hedge fund based in San Francisco. And here we have their logo. Well, but Numerai being a hedge fund on itself is not that interesting. What's interesting is how it is run as opposed to a traditional hedge fund. So let's suppose we have a traditional hedge fund called H. What they do is that they hire a bunch of machine learning engineers and data scientists. And what these data scientists and machine learning engineers do is that they create models of the financial market, right? And then the hedge fund has infrastructure to run these models, from which predictions of this financial market is made. And then the hedge fund uses these predictions to make profits. That's how a traditional hedge fund operates. How the Numerai hedge fund operates is much more interesting. So the Numerai hedge fund does not hire any machine learning engineers or data scientists. So instead, it hosts this data science tournament, right? It hosts this data science tournament where capable individuals out in the wild can access data published through the tournament and build their own models. Right? Everyone can build a different model. And what they do is that they submit these models into the competition. And then the Numerai hedge fund evaluates how much predicting power these models have in the financial market. And then they're going to use the best models to make their predictions in the financial market, and that's how they make profits. And what we're going to do here is we're going to play the role of these capable individuals and participate in a Numerai data science tournament where we build our own machine learning models to predict the financial market with the data that the hedge fund provides through its tournament. And hopefully we can also get some rewards from the hedge fund if our model is good, but I'll come to that later. So now I'm going to give a very brief tour of what exactly we're doing in the tournament. So here we're on the homepage of the Numerai Data Science tournament. So the tournament happens in weekly rounds, where each week we need to submit the predictions that our model generates here at their website. And this is also here where we download their data, their training data to train our model. So in order to do so, you need to first create an account. I have already created an account using our official club email. And once you downloaded the data and unzipped it, what you will have are these files here, as shown in this folder. So here I have them sorted by size. Let's make that bigger. Oops. Well, here I have them sorted by size, sorted by file size. You will notice that the biggest file here is this Numerai training data.parquet file. So first of all, what is a Parquet? Well, a Parquet is essentially just an Excel spreadsheet on steroids. What its advantages over CSV files and Excel spreadsheets is that it's very efficient at handling large quantities of data. So its input and output time is significantly shorter compared to, say, a CSV file or an Excel spreadsheet. And it's also much more compact, meaning that given the same amount of data points, a Parquet file will be much smaller than a CSV file or an Excel spreadsheet. So you can open it like with a application, with a particular application that I will post in the resources, just like an Excel file or a CSV file. And this is what it looks like once you open it. So here on the columns, we have, let's go back to the very first column. First column, we have era, which is like the time component of the data that they provide us. And now we have a bunch of features here. The feature names are intentionally obfuscated by the hedge fund because data is valuable. The hedge fund uses the profit that it makes off our models to purchase very clean, very high temporal resolution data from different firms. But they're not gonna just give it to us for free. Otherwise, they can't make any money if we do the same thing as they do. So only they know what these features mean. We don't know what these features mean. We just know just some numbers representing some predictive, some features with predictive power in the financial market. And each column we have era, and we also have at the end an ID. So each ID corresponds to a different financial asset. Say it could be Bitcoin or Tesla stock. But again, the asset name, or rather the ID, is intentionally obfuscated. So we don't know which stock this ID exactly corresponds to, but the hedge fund people know. Our job is only to derive some correlation, derive a model that predicts how the stock does given these features we have. And here we also have a bunch of still do those columns. So we have a lot of features. Our feature space will be in very high dimensional space. And towards the end here, we have targets. This is what we are trying to predict. There are also, as we can see here, there's a lot of different targets. But if we look at the format that they want us to submit our predictions in, we're only submitting one, our prediction for one target, which is a value between 0 and 1. But here in the training set, we have a bunch of different targets. So what's going on here? What's going on here is explained in this file, analysis and tips, this Jupyter notebook file, which I will open right now. So here, there are 20 different targets, but we are only scored on one target, which currently corresponds to this target name, target NAMI 20. So if we want to build our models, we can only care about this. Let's find where target NAMI 20 is. Yes, so we can only base our predictions on target NAMI 20 over here. But apparently, the other targets are also helpful in building a very good model. But given the general architecture of our project, which I will go into later, our prediction doesn't have to be, our individual models don't have to be very good. So it's okay if you want to use the other targets to build your prediction, but I would recommend as beginners for us to only focus on predicting target NAMI 20 using all these different features that they have provided us with. So as a summary, we're given, let's say, almost 100, more than 100 different features that might have some varying degrees of predictive power in the financial market. And what we are trying to do is to output for each ID over here. So we perform some sort of regression. For each ID, we predict a number, a floating point number ranging from 0 to 1. And every week, we submit it to the hedge fund. And they're going to tell us how we did every week based on our submissions. And also, I have to mention that in order to even qualify for each week's round, there are two different criteria that we have to satisfy, that our model has to satisfy. First is obviously how good our models are, so the predictive power our models are. There's a certain threshold our model needs to hit to even qualify for the competition, because running these models and like going through these models takes computational resources, right? The hedge fund doesn't want just anyone to submit a really bad model for them to look through it. That would cost them a lot of money. So first, our model needs to be good enough. Second, our model needs to be original. That means we can't just copy paste someone else's model and use it as our submission. So we need to come up with something original in order to even qualify for the competition. So this is generally the overview. So now let's talk about the model that we're going to build for the competition. So what exactly are we going to do for the competition? As I have previously mentioned, the competition is about building this regression algorithm in extremely high dimensional feature space that outputs a number between 0 and 1. And after talking to a lot of you personally, what I realized is that most of us here are relatively new to the field of machine learning. So what you guys have been telling me is that you would much rather this be a learning experience for everyone, where you get to implement a simple model, simple regression model from start to finish, instead of working on parts of a monolith, extremely elaborate model for the competition. So here's how we're gonna do this. So for everyone on the team currently, everyone's gonna build their own model, right? It could be as simple or as complicated as you want it to be. Like, for example, person A could do a linear regression model. Person B can do an SVM regression model. C could do random forest. And D could do some sort of gradient boosted tree. Right? So everyone is going to implement their own regression algorithm on the dataset provided. Notice that I have talked about the two different metrics that we need to satisfy in order to qualify for the competition. So individually, none of our model, I expect none of our models to pass the correlation metric, namely like how good our models are. So we could, like, individually we could build very bad models, but here's what makes our model interesting. So every single one of our so to speak bad models are going to individually output a number between 0 and 1, right? So based on the output of every single one of our individual models, we're going to do another layer of regression with this algorithm called the gradient boosted tree. So the output that our individual not so good models outputs will be our new feature space. Now, using the gradient boosted tree algorithm, we're gonna finally output what we think what our final prediction is as a number between 0 and 1 for each asset ID on the data set. So let me just give you a brief overview of how the gradient boosted tree algorithm works and give you an intuition why this might result in a qualifying original model. So essentially, what the gradient boosted tree does is that it starts with a hyperplane in our high-dimensional feature space, and it is very similar to gradient descent. So what it does is that it gradually pushes different regions of this hyperplane up or down in the direction in our output space. So let's say it could push this region up, and this region could be pushed down, and you get the idea. So at the end, after however many iterations that we wanted to run, it could turn basically morph this hyperplane into some very complicated shape. And going back to our architecture, basically the intuition is that the gradient boosted tree is gonna look at what our individual models predict and perform regression upon that to decide which model best predicts which subset of the original feature space, and it weighs our predictions according to how good does it think it models that part of that data set. So the more machine learning attuned of you might notice that this looks very similar to a one-layer neural network. And yes, essentially in an abstract way, what we are building is a one-layer neural network. So this really gives us the flexibility of if new members want to join the project, they could just work on another one of these simple models that eventually gets plugged into our gradient boosted tree. And if another member decides to leave the project, that doesn't break our entire model. So ideally, every one of us should work on a different type of regression algorithm as their sort of sub-model under the umbrella of our gradient boosted tree. So in theory, the more diverse our sub-umbrella of regression algorithms are, the better this algorithm will work in theory. So this is essentially what we're doing. To summarize, everyone is going to build their own regression algorithm on the provided Numerai dataset, and everyone's algorithm will output a number between 0 and 1. And on top of that, we're going to do another layer of regression based on how the zeros and the numbers between 0 and 1 that everyone's model outputs. We're going to do regression on that and output our final prediction as a number between 0 and 1. So everyone will get the chance to build their own regression algorithm from start to finish, and it could be as simple as simple linear regression, or it could be as complicated as you want it to be. But the only thing is that all these different algorithms needs to be ideally different from one another. So we have a diverse portfolio of different regression algorithms under our umbrella, and that should make this architecture very powerful. At least it should let us qualify Numerai data science. So that is what we're planning to do. And the timeline of the project. So first of all, true to the decentralized nature of the Numerai project, the entire tournament as a whole, we will be hosting this project entirely online and asynchronous. Of course, we will host in-person huddles and events pertaining to this project in the future, but those are optional. To be considered a part of the team, you just have to follow the timeline that I'm about to present and submit a working model by these by the relevant deadlines. So in terms of timeline, I realize that we are all U of T students. We all have very little free time. So I want to make it as flexible as possible. So from the time between now and the Christmas break, we're gonna call this the research phase of our project. So what we do during the research phase is to decide on which individual models under the grand umbrella of our gradient boosted tree that you want to build. Again, to reiterate, it could be as simple or as complicated as you want. Depends on how much time you want to dedicate to this project. But the only criteria is that they have to be unique. Each and every single one of the individual regression algorithms needs to be unique. So how this is going to work is that once you've decided on an algorithm, say if you want to do a random forest regression algorithm on the Numerai dataset, so you should shout it out in our Discord server, tell everyone, hey, I'm building random forest is now mine. Then I will assign the role of the random forest engineer to you on Discord, and say someone else in future comes along and say, hey, random forest sounds like a great idea. They can't do that anymore because you are building random forest. They need to think about another regression algorithm. And that works in a first come, first serve basis. So I would encourage you to start looking at different algorithms, maybe spend a Friday night going through what popular regression algorithms there are and which one do you think will be the easiest to implement or will work the best for the data set provided, and then quickly take the ones that you want to implement before it is taken by someone else. And that is our research phase. So before Christmas break, decide on what algorithm you want to build to be considered a part of the team. And then during the winter break, we'll call it the prototyping phase. So what we do during the prototyping phase is that we're going to try to implement a working model of the algorithm that we have selected during the research phase. So by the end of the by the end of the Christmas break, I would expect everyone who's part of the team to have completed at least a somewhat partially working prototype of their regression algorithm. And then between the end of the winter break and the 2022 reading week, we're going to call it the improvement phase. Right. So during this phase, you're going to improve on the prototype that you built. So by the reading week of 2022, I would expect a fully functional model that could be plugged into our gradient boosted tree to perform regression. And during the reading week of 2022, we are going to So between the start of the reading week of 2022 and the summer break, we are going to implement our top layer gradient boosted tree that performs our top level regression here. And after we have done that, have all your models plugged into our top level GBD tree, we're gonna officially enter the tournament, begin the summer break of 2022. So enter tournament. Okay, so this is basically the timeline of the project. So start reading some papers. So finally, I would like to talk a bit about the future of this project. So basically what we stand to gain if we build a really good model. So as I mentioned previously, the Numerai hedge fund rewards our citizen data scientists and machine learning engineers based on how good their model performs in the Numerai data science tournament. And how they do that is through this cryptocurrency that they created called Numerai, or at least that's how I think it's supposed to be pronounced. And how we earn Numerai with our model is that we stake it. Basically, staking means we first need to buy some Numerai and invest it into our model. And if our model performs well, we will earn additional Numerai as a percentage of how much Numerai we invested initially. And if our model doesn't perform well, let's say the correlation with the actual movement of the financial market is negative, a portion of our Numerai that we invested will be burned. So we could also stand to make losses if our models don't perform well. So if by summer of 2022, our model has proven itself to consistently perform well, we could start thinking about reaping our rewards from this project. So we could invest, we could invest in our model, or we could get potentially some sponsors to invest in our model. So this is basically the future of this project. And also additionally, personally for you, this project will familiarize you with the Numerai data science tournament ecosystem. So a lot of very intelligent people working for, let's say, SpaceX, Tesla, NASA, they participate in the competition as a part-time job to earn additional income. So maybe after, let's say, when we graduate, we might not necessarily work in the financial industry, but this could totally be one of our part-time jobs, just to maintain a very well-written model and stake Numerai on it. Stake Numerai, the cryptocurrency, on it. And yeah, so this is essentially the Numerai data science tournament project. And yeah, cheers.